Hi everybody, my name is Renato Mauricio Toasa, and I presented the paper named Monitoring of an Industrial Process based on Industry 4.0. This is a work made by four authors, Mauricio Javier López Flores, Elvis Román López Flores, Francisco Javier Galora Silva, and me, Renato Toas. This work is important because currently there has been a substantial technological improvement in the industrial control rooms that are responsible for monitoring the manufacturing process. In this sense, this article proposed the development of a monitoring platform through the MQTT communication protocol using accessible equipment and a publication subscription model on WebSockets. The platform is simulated on Factor.io software operated by a programmable logic controller, PLC. Its visualization and monitoring are online through a web page, disponible in a web server. After performance and response tests, it is determined that the communication platform achieves adequate and complete operability. Its applicability is simple, scalability characteristics, and adequate level of messaging quality, security, and special communication in restricted environments. Okay, so we present the introduction about this work. In today's environments of global competition, technological development, and innovation companies, especially in manufacturing, are forced to constantly reconfigure this process. The concept of Industry 4.0, based on a smart manufacturing approach, is part of this transformation, in which manufacturing and information technologies have been integrated to create innovative manufacturing, management, and business systems that optimize manufacturing process, achieve greater flexibility, efficiency, and generate a value proposition for their customers, as well as respond in a timely manner to the needs of their markets. The methodology of this work is by architecture, PLC Factor.io, PLC Raspberry Pi, WebSockets, and QoS and security, or quality of service of this platform. This is the architecture of the proposed system to control manufacturing process. We have Factor.io, Ethernet TCP/IP for communication, and a controller, a programming with Python, and the MQTT client on Raspberry Pi. The server is Mosquito Broker. It's permit to subscribe to posts and send and post a message by WebSockets and show in a web page disponible in a web server allowed in internet. We have MQTT clients, web navigator, and monitoring by a computer of people around in this manufacturing industry. PLC and Factor.io. The industrial process plant consists of two parts. The first, the assembly of a material using conveyor belts and armed with X and Z movement. And the second, a tank with level control for filling and emptying. The physical layout of the plant is simulated in Factor.io software with direct connection to the programmable logic controller, or PLC. We can see factory I/O, IP address, protocols IP, and the controller system, PLC Siemens S7-112, and IP address of controller of this system. After we have PLC and Raspberry Pi. The data communication between the programmable logic controller, PLC, and the Raspberry Pi to be used as a client is established by means of the multi-platform programming tool Snap 7, allowing to obtain the data from PLC systems through the Profinet protocol as Profibus Ethernet by Raspberry Pi. We can see this device. After we have the WebSockets, the application and development of the web page is supported by the use of MQTT protocol over WebSockets, which in general allows sending and receiving messages directly from two browsers, client and servers. In addition to being able to operate all the features and functions of the MQTT as usual, we can see the architecture of this communication. We have MQTT Mosquito Broker as a server, el data package MQTT, SPP protocol, and over web sockets by the communication. And we can see all information, all data on the web navigator and by the MQTT client. Okay. QoS and security. The quality of service QoS used in the project to define the guarantee of reception of a specific message was mostly zero, due to the characteristics of the network, such as its reliability level and the improved application logic. In addition, the network processes a reliable communication at most stable connection of the system. We assegurate the quality of service of communication by TCL communication, TCL configuration on the server Mosquito of MQTT, TLS, or HTTPS. We can see the communication. The platform has a smooth of dynamic operation with a perceptive real-time response and admissible characteristic of operability and control. Okay, we can see the general architecture of communication of proposed system to monitoring and industrial process by Industry 4.0. So we have the conclusions. The implemented platform based on the concept of Industry 4.0 allows the complete integration of the development process units and evidence applicable and important approach to the industrial transformation so necessary in our country, Ecuador. Evolution achievement based on the technical knowledge, processes, and using open source device, adaptable, no one above all accessible to the user. MQTT is a relatively easy to implement, lightweight and open messaging protocol that allows communication in restricted environments. It is scalable, bandwidth efficient, enables quality of service, and allows message encryption. This is important to guarantee the privacy of communication of client and server by MQTT broker in the system. The development platform is online, consists of two clients. The process is controlled by a PLC simulate in factor I/O software and is communication with the browser client through WebSockets. After the test operation, response and network traffic analysis, the proposal presents appropriate characteristics and functionality, robust scalability and security for the users of this system. This is the presentation of the work. Thanks and see you later, everybody.